So functions are really cool in that we can do some common algebra with them and combining functions together. So one of the things we can do is if we are going to add two functions together, we can get an output of two separate functions added. Likewise, if I want to figure out what subtracting them would be as a function, I can subtract g of x from f of x. Going along the same idea, if I want to times two functions together, that's just the two of them multiplied together. And lastly, if I want to divide two functions, that's just f of x divided by g of x. So what this looks like, if we're given two functions, say f of x is equal to x squared plus 2x, and g of x is equal to 3x minus 1. This means that I can figure out these things given two separate functions. So say for example, I want to figure out what f plus g of x is. Well, that's just f plus g. So f is x squared plus 2x plus g is 3x minus 1. So to find our complete function, we combine like terms. X squared, there's only one of it, so it's by itself. 2x plus 3x gives me 5x and minus 1. So these two functions being added together would be x squared plus 5x minus 1. Same idea if we took and wanted to find what's f minus g, but not just of x. Let's say we want to find of negative 2. There's two ways you can do this. You can either evaluate each function at negative 2 and then subtract one from the other, or subtract them, then evaluate. You'll get the same answer. So I like to do subtract, then evaluate. So if we're going to subtract, we're going to take f minus g. So f minus g. So x squared minus 2x. And I like to keep them in parentheses because what happens is if I don't put g in parentheses, I forget to take this negative all the way through the function. And so what this looks like is minus 3x plus 1, or x squared minus 5x plus 1. Excuse me, plus 2x would be minus x. It's a good thing to double check yourself. So I'm wanting to evaluate this for negative 2, not x though. So my last step would be sticking negative 2 in for x to evaluate. Negative 2 squared is 4 plus 2 plus 1. So I get a total of 7. So when I evaluate f minus g at negative 2, I get 7. Say I want to times the two, f times g of x. Well, f is x squared plus 2x times g, 3x minus 1. To times these two, we're going to have to plot a method called foiling. So we go first, x squared times 3x is 3x cubed, so we add their powers. X squared times negative 1, negative x squared, plus 6x squared minus 2x. Combining our like terms in the middle, 3x cubed plus 5x squared minus 2x would be the two equations multiplied. So lastly, to do the two equations divided, if we want to know what this is, we would say f x squared plus 2x, so x squared plus 2x divided by g. Well, g is 3x minus 1. So 3x minus 1. This would be our function for this. So say we want to, instead of evaluate at x, we want to figure out what's f divided by g at 1. Then we would just stick 1 in for our x values and get 1 squared plus 2 times 1 all over 3 times 1 minus 1. 1 plus 2 gives me 3. 3 minus 1 gives me 2. And so f divided by g evaluated at 1 would be 3/2. So you can do this, these algebraic functions, with any of your functions given an f and a g, and make these type of functions where they're built on smaller functions, and they all follow these key rules. You can then evaluate them at different values. An interesting thing to note is when we want to find out the sum of two functions, it's literally the sum of their individual heights. So if we were looking at a graph, we could actually find out each height individually and add them together to find out the sum of what they would be. Likewise with any of these other outputs as well.